is chapter 7.4, practice C, number 19. It's on logarithms, and it's graphing a logarithm. I adjusted number 19 a little bit. I added a k right here, this -1, just so that we can have a little bit of variation. But the question says to graph this, and I'm saying to start by graphing the parent function, label at least 3 points on the final graph, and identify the final graph with a particular color. Then I'm going to say state the domain and range. So let's start out by figuring out how to graph this thing. Graph wizard. Okay. Put my graph over here. So I want to start with my parent function. And my parent function here is f of x equals log 2x. So, like, when we're talking about parent functions, just so we can try and be a little bit more clear, you know how I have when we talk about transformations, we talk about it in terms of a times f of x minus h plus k. And the a is our vertical stretch or compress, the h is our horizontal shift, and the k is our vertical shift. Well, what we want to do when we talk about a parent function is we want to look at what is this function right here without any a's, h's, or k's. Well, I don't have an a, I do have an h, I do have a k, and I want to talk about what it's like without all of those. That's why I got to log 2x. So how are we going to graph log 2x? Well, what I'm going to do first is I'm going to make this a y. So I'm dealing with something very specific. So y equals log 2x. And it's very hard to plug in x values and get y, because I don't know what those values are. Logarithms are difficult. There are a lot of decimal points, and it's kind of complicated. But I do know that the exponential equivalent of this is 2 to the y equals x. And it's very important to understand how these two things relate. My parent function that I wrote up here is asking me a question. It's saying I have a base 2 and an exponent y. So if I take my base 2 and I put the exponent y on it, I'm going to get x. Well, look at my exponential equivalent. Base 2 exponent y equals x. Same thing. But this one is a whole lot easier to graph. I'm going to make a table. I recommend that you make a table. X, y, here we go. But in this instance here, I'm going to start with my y values. And we know with an exponential function, which this is the exponential equivalent, I have 3 key points. I have 0, 1, and -1. And because I'm graphing it kind of like with 2 to the y equals x, I want my y values for that. That'll make it easier to find the x values. So when y is 0, 2 to the 0, everything to the 0th power is 1. When y is 1, everything to the 1 power is itself. So x is 2. When y is -1, this will be my reciprocal. It'll be 1/2. And because I made this nice little chart, I now have some coordinate points, x, y points that I can plot for my logarithmic graph. I have x equals 1, y equals 0. I have x equals 2, y equals 1. And I have x equals 1/2, y equals -1. And this is going to take the shape that I know and that you need to know. Logarithmic graphs always have the same kind of a shape. When they're a parent function, the y-axis is going to be an asymptote, and they're going to keep going on like that. That is the basic shape of a logarithmic graph. You need to know that. And the graph also makes some sense when you remember what is the domain of a logarithm. So I'm going to go back up to my parent function here. I have log x. X has to be greater than 0. X has to be greater than 0. And sure enough, my domain, my asymptote, my vertical asymptote is the y-axis, which is x equals 0. And all my x values are greater than 0. So my graph is kind of making sense compared to what I know my domain has to be. Well, now I'm going to go back up to my transformed function, and I see that I have an h and a k. I don't have any a. There's no a here, so I don't have to worry about any vertical stretch or compresses. I don't have any negative sign, so I don't need to worry about flipping it. All I need to do is I need to go, well, since it's a positive 2 here, I know I need to go left 2, and I need to go down 1. So every point, I'm going to move left 2, down 1. So I'm going to go 1, 2. I'm going to mark this here. 1, 2, and I'm going to. I'm going to go 1, 2, and down 1. So this point right here, it was 1/2 negative 1. Now I've moved left 2, so it's negative 1.5, comma, down 1, negative 2. Actually, I'm going to pause here for a second, because what I should have done, and I didn't, is I first should have moved my asymptote. And since I have a vertical asymptote on a logarithmic graph, that means my graph is going to shift. If my graph is going to shift horizontally, I have to redraw in my asymptote. And my asymptote is also, like the rest of my graph, going to shift over 2. So my asymptote has now changed to negative 2, from 0 to negative 2. And I really should have done that first. Okay? So I had that first point. My second point was 1, 0. I'm going to move to the left 2 and down 1. Nice big point. So that point is negative 1, negative 1. And then my last point here was at 2, 1. I'm going to move to left 2 and down 1. So now I'm at my origin. I'm at 0, 0. That's my third point. I know what the graph is supposed to look like. I know I have my asymptote here. I can draw in the graph just like that. So the next part of the question says, what is the domain and the range? Well, I can do that in 2 ways. One is I can look at my graph, and I can see my domain, which are my x values. They start at negative 2, they don't include negative 2, and they go on that way forever. So my domain, my graph, looks like it starts at negative 2, doesn't touch it, that's why it's a parentheses, and it goes to infinity. And my range on the graph is very clearly, I'm going all the way down to infinity, and this, even though it goes up slowly, it keeps going up. So my range is negative infinity to infinity, all real numbers. And if I look back at my function here, well, when I look at domain, I know that if it's a logarithm, I cannot have a negative argument. So I know, I'm going to write over here, where am I going to write? I'm going to write, I'll write down here. I know that x plus 2, the argument of my logarithm right here, has to be greater than 0. Well, that means x has to be greater than negative 2. And that matches up perfectly with my graph. As far as range goes, I mean, I could find the inverse, and maybe I'll do that on another problem. But I can see that the range, and the range of all logarithmic functions, is all real numbers. So that is how you do this problem 7.4, number 19.